Hello coders, in this video we will solve next question in our LeetCode 75 list. So let's see what the question is. Let me take you to the screen first. And yeah, here. This is the question, which is odd even linked list. What the question says, that given the head of singly linked list, group all the nodes with odd indices together followed by the nodes with even indices. I return the reordered list. The first node is considered odd and the second node is even, and so on. Basically 1, 2, 3, 4, 5 likewise. Note that the relative order inside both the even and odd groups should remain as it was in the input. Basically they are saying ki we need to group odd indices node in one group, and in second group we need to take all nodes of even indices. And for that what they are saying ki first node will be considered as odd, then second node is even, then again odd, then again even. Likewise it will be on, like it will be like this only ki, and it will be so on, odd even. So let's see what the example, then like we'll understand what question is saying. Basically we have given a linked list that is 1, 2, 3, 4, 5. This is the linked list. We need to group all odd indiced nodes, that is 1, 3 and 5, and then we need to append, like we need to attach it to the even indiced group nodes, like 2 and 4, the 2 and 4 here, and after 5 we have to link it to the 2, 2, 4 likewise. Let's see the second example. This is the second example. It is 2, 1, 3, 5, 6, 4, 7. We need to take odd indiced nodes first, then we need to take even indiced nodes. So odd indiced nodes, which are the odd indiced nodes? 2, 3, 6, 7, this, and even indiced nodes are 1, 5, 4. These are this, and we need to append it after odd. So first odd ones, that is 2, 3, 6, 7, then we have 1, 5 and 4. So likewise we need to solve it. So what the first thing coming in my mind, that let's store in two vectors, that is in odd indiced nodes in one vector, and or in one vector only we'll store first odd ones, then we'll store even ones, and then we will copy that data in that vector to the linked list. Basically what I'm saying, we'll take a pointer and we'll take a not continuous one, the we will skip for next, and then we'll take the next one. Likewise we'll take one, then we'll skip the second two, and then we'll keep again three, then we'll skip four, then we'll take five. Ended it, and we'll again start with heads next, that is from two, then we'll take two, then we'll skip its next, that is three, and then we'll take its next, that is four. And again we will travel like this will we will store in a vector, that is in vector we'll store this all, and then we'll copy this thing to the linked list again, that is 1, 3, 5 and 2, 4. That's what we want. Same thing if we do here. Let's take this example. First we will take head, from head we'll take it, then we'll skip the next one, that is 1, then we'll go to the third, then when we go to the 5 we'll skip it, then we'll go 6, we'll take it, then we'll go 4, we'll skip it, then we'll go 7, we'll take it, and again we'll start for the even thing, like even nodes. We'll start from 1 and we'll take it, then when we go to the 3 we'll skip it, then 5 we'll take it, then we'll skip 6, and then we'll take 4, and then we'll skip 7, and then we have null that we don't take, and then we will copy this again to the same linked list, and we'll get the same thing. Like if we copy this data to the linked list, then we get the same thing, like 2, 3, 6, 7, 1, 5, 4. So but for this what we did here, we traversed linked list two times, that is and again we traverse linked list to copy the data, that is we traverse linked list three times, and additionally we store this data in a vector, that is we took big of n space. So what happened here, we took the space big of n, but in the last what is said, you must solve the problem in big of one extra space complexity only. So here we have solved the example, but we did it in big of we are taking big of n task space complexity and big of n time complexity. Time complexity is fine, but space complexity we are taking more. Uh, so how we can reduce it? So first, see what I told you, like brute force thing, that brute force example that I have explained here, that code first, and let's see will that work or not. Let's take a vector, and we know it's int, the data in that linked list is int, so vector int and the data, and we'll take a node head. First we will take a pointer which will point to the first node, head node star, the first one, which is, yeah, the first one, or we can say the current node, and the current node will be the head. What we will do, while my current isn't null, like while my current is not equal to null, we'll traverse it, right? And we are taking uh, for this, like this loop will be for odd one, for odd nodes, for odd nodes data. So we'll take the data and we'll skip the next. Okay, that we need to remember, like in both the case, even and odd, we need to skip, but for right now we are taking the odd data. So we are at current is equals to head, we'll take data dot push back, we'll take the data that is current's value, and we'll go to the next. Current will go current's next, but we have to skip this, so we'll go to current equals to current next again. But here what can happen, ki current equals to current next can be null, right? So we have to put a condition here that if current, then go next. Okay, we have to skip one. For that we are doing this step. We can write it here, ki to skip a one node, we have to do this. Okay, and then we will do the same thing for even node. This is for even node data. This time the current will be current equals to current's next, right? And we'll do this. Cause why did this current equal current next? But we want even data here. To take the even data, first the odd, and then we have even. So we did this, the current equals to current next. To take the even data, we did this, and then we have to copy this data to again our original list. So we'll take current equals to head and index equals to 0, while my current not equals to null. We have data, like how much data in linked list, that much data in vectors. So we don't need to mention this condition, like index not equals to data dot size. If you're right, then also right, but this basically one thing is explaining other one. Like if current not equals to null, basically when the current equals to null, at that time the index will be equal to data dot size. So either condition is fine. Now what we will do, current data will basically we will copying the data from the data. Current value will be the data at that index. We are updating the data based on the data which we have stored in the data vector. Current equals to current next and index plus plus, yeah, and then we will return head. But we wrote this all, but what if uh, there is no head? Like if head is there is no nodes, like head is equals to null, then this may cause error, right? So initially what we will do here, ki if we'll write condition ki if my head is equals to null, like there is no node in the linked list, or if there is one node also, then we don't need to do all this, right? Because if there is only one node, we need to return the that node only. That is, if head next is equals to null, heads next equals to null, then we need to return head only. And if heads next and its next, that is if we have only two nodes, then already we have odd and even, right? And we don't then we don't need to go the third. We if don't have the third node, then why we go there, right? So if the heads next is equals to null, then we'll return the head only. And yeah, likewise we'll do. And let's say if this form, what it's saying, member x is not null pointer type node, current data, okay, we need to just current equals to head, or we should do here, because when the current was null, at that time this loop was ended, and that the condition, like we can't take nulls next, right? So that's why it failed. And check it now and submit it. It works, but it taking space complexity big of n, that we can see here, and also here, like big of n, and that we don't want, because they have mentioned it explicitly here. You must solve the problem big of 1. So can we solve it? That will be solved in our next video. Till then, okay, bye.